All right. In this presentation, I address the prevalence of the idea of an average person or student in psychology and education from a methodological perspective. How often do we hear the phrase average student to categorize learners as mediocre? If some are mediocre, of course, others are exceptional in whatever manner of attribute. Despite widespread use in daily life, the idea of an average student in psychology and education is largely based on statistical considerations rather than experimental or experiential necessity. Can you hear me?
Yes.
Good. So such consolatory statements as, quote, average people as students or students are also great. It's just that they may not get noticed and recognized as publicly, end of quote, is sometimes warranted. We have to ask ourselves why there is so much focus on the average person or student in psychology and education if both disciplines presumably are essentially studies of the individual. The answer is rooted in the historical marriage of measurement and inferential statistics, broadly speaking, and particularly between that of measurement error and statistical control, as opposed to experimental control, that is. Considering the definition of psychology and education is a good place to begin a methodological critique of this phenomenon. It is now standard to define psychology as the scientific study of behavior and mental processes, presumably of the individual subject, human or animal. The focus on the individual, of course, is what differentiates psychology from sociology or anthropology. The definition of education is less precise and more varied, but a common theme is often learning and acquisition of knowledge, again, by the individual subject, in this case, perhaps the human subject. Despite the central interest in the individual person or student as the putative subject in psychology and education, the predominant experimental methodology in both disciplines is focused on averages because of the heavy reliance on large N group designs that are strictly tied to inferential statistics, which mostly take the form of null hypothesis statistical testing or NHST in both disciplines. Two additional inferential approaches that are considerably less common are the estimation approach and Bayesian approach. At any rate, the three approaches rely on computation of the mean to make sense of data. To illustrate the prevalence, the pervasiveness of group designs and the attendant reliance on inferential statistics, let's consider the topical coverage of designs and statistics in research methods textbooks. A cursory survey of some such textbooks in psychology and education revealed that in both disciplines, research method textbooks, one, substantially more space is devoted to group designs than to single subject designs, shown in red on the right. Two, substantially more space is devoted to NHST than to estimation, and none at all to Bayesian approach to inferential statistics, shown in green on the left. The three inferential statistical approaches require the mean for their respective roles in interpreting experimental data in psychology and education. So just to reiterate, because of the pervasive use of group designs that require mean measures for experimental work in both disciplines, all the inferential statistical approaches treat the average person or student as the putative subject of interest in psychology and education. In reality, though, more often than not, it is the individual person or student who learns, not some non-existent average person or student. The use of the three statistical approaches, particularly NHST, has resulted in various adverse consequences for psychology and education, including multiple replication failures. If this is the case, what then? Well, a largely ignored alternative to group designs that has a long and productive history in psychology, in education, and in medicine. What's that? Small n single subject designs, usually focused solely on the individual, the situation, or setting, mostly the individual. Studying only a few of them at a time, each extensively exposed to various conditions of the relevant variables, each exposure lasting until measurement stability. The real benefit is that they reveal functional relationships between behavior and environmental conditions. In education, such environments can range from the school, the classroom, or teacher variables to teaching methods, materials, and/or technology. The online version of my presentation has 3 examples from education to illustrate how small n research works to preserve the ontological status of the individual. But in the interest of time, I will talk about only one of them here. Monroe and Stephenson reported on the study of active responding in a vocabulary classroom with 10 to 11-year-olds of different nationalities. They compared hand raising to the use of response cards in different conditions in an ABAB design. The students' results showed that active responding increased for each child when they were using response cards compared to using hand raising. So the first column and second column is hand raising, the second and fourth is response card. If these kids had formed a response card experimental group in a group design, the group mean would have been reported, missing out on reporting the peculiarities of Alice's data shown with the arrows there in average snapshot. Revisiting the adverse group design outcomes mentioned earlier, we find that they are non-existent in the small n designs. P-hacking doesn't occur, it's utterly irrelevant. Replication is built in to the system, and replication ensures generality. And the question of lack of cumulative science is mute when you use small n design. And whenever the mean is used, it is not used to define the individual student. There are a couple of implications of broader adoption of small n designs. The first one is that it will focus attention on mastery in education instead of perpetuating mediocrity by implication on account of the average student. There is a long history in education with personalized system of instruction, or PSI, most common in hard sciences like physics, and now even more with instructional design advances afforded by computers and artificial intelligence. Second implication is that we will require a significant shift in how we approach asking questions, no more pre-experimental statistical considerations, collecting data, no more snapshot average measures, extensive in-depth study will be conducted instead, analyzing and interpreting data, statistics retire, closer to reality instead, and making research and practice decisions based on revealed functional relationships, not statistical imperatives. In conclusion, there is nothing that is inherently wrong with the average measure per se. The real culprit is how we have been using it to make sense of data that we have encountered in our attempts to quantify nature and humanity. In good stead, we are not condemned to live with the average student side effect of our heavy reliance on large N group designs, whose usually inadequate implementation has been responsible for the myriad of methodological problems, including replication failures. There are demonstrable, effective, viable alternatives in small N single subject designs that remove the cloak of mediocrity that inadvertently adorns many putative subjects in psychology and education. These designs ought to be more widely adopted for the myriad of methodological advantages they bring to the table. Not doing so is like repeating the same mistake over and over and expecting a different result. Thank you for your attention. I'll take any questions.
Thank you very much.